In this video, we'll see the exponential rules and logarithm rules in details. Let us start with the exponential rules. We have two numbers a to the power m and a to the power n and their times. We can write a to the power m times a to the power n equals a to the power m plus n. When there is multiplication, the powers are added in the right side. Again, in formula number 2, we have two numbers multiplied, a times b whole to the power m. We can write this as equal a to the power m times b to the power m. The power is separately assigned with the two numbers with a multiplication sign in the middle. So this is formula number 2. Formula number 3, a to the power m divide a to the power n equals a to the power m by a to the power n equals a to the power m minus n. In case of division, the powers are subtracted from each other. The power of the numerator minus the power of the denominator. This is just opposite to the multiplication formula. In case of multiplication, the powers are added. In case of division, the powers are subtracted from each other. This is formula number 3. Formula number 4, a divide b whole to the power m equals a by b whole to the power m equals a to the power m divide b to the power m. In this case, power is separately assigned with the two numbers and with a division sign. This is formula number 4. Formula number 5, a to the power m whole to the power n equals a to the power mn. In this case, the powers are multiplied with each other when there is power inside and outside. Formula number 6, a to the power minus m equals 1 by a to the power m. So when there is a minus sign in front of the power, we can write 1 by plus sign of that power. So 1 by a to the power m. Similarly, we can write formula number 7, 1 by a to the power n equals a to the power minus n. Formula number 8, a to the power 1 by m whole to the power m equals a. In this case, 1 by m times m, so m are cancelled, so we get a. Formula number 9, square root of a equals a to the power half, because square root represents half. Formula number 10, nth root of a equals a to the power 1 by n, where n is 3, 4, 5, etc. Formula number 11, if a to the power m equals b to the power m, then we can write a equals b. Since the powers are equal, so the bases should be equal. This is formula number 11. Formula number 12, if a to the power m equals a to the power n, in this case, the powers are different, but the bases are equal. Then we can write the powers are equal, m equals n. This is formula number 12. Formula number 13, if a to the power m equals 1 by a to the power minus n, then we can write m equals n. Formula number 14, if a to the power m equals b, then we can write a equals b to the power 1 by m. This is formula number 14. Formula number 15, if a to the power 1 by m equals b, then we can write a equals b to the power m. Next, formula 16, if a to the power minus 1 equals v, then we can write a equals b to the power minus 1 or a equals 1 by b, because b to the power minus 1 can be written as 1 by b. So these are the basic formulas for exponential terms. Next, we'll move to the logarithm rules. If b to the power p equals n, then logarithm or log is defined as log b base n equals p. So the b goes as the base of the log and the n number comes with the log and equals the power. So this is how log is defined, where b is the base, p is the power, and n is the number or result. Formula number 2, log b base 1 equals 0. Formula number 3, log b base b equals 1. Formula number 4, log b base a equals 1 by log a base b. For example, if we have log 3, 2, we can write this as 1 by log 2, 3. So in reciprocal case, the base becomes the number and the number becomes the base. This is formula number 4. Formula number 5, log b base a times log a base b equals 1. If the bases becomes the number and the number becomes the base, if these two types of logs are multiplied, we get 1. This is formula number 5. Formula number 6, log b base m times n equals log b base m plus log b base n. In case of multiplication, the two logs are added. Formula number 7, log b base m by n equals log b base m minus log b base n. So in case of division, the logs are subtracted from each other. The term in the numerator comes first and the term in the denominator comes second in the subtraction. Formula number 8, log b base n to the power m equals m times log b base n. So the power of the number comes as the coefficient of the log. This is formula number 8. So the power m comes as the coefficient of the log. Formula number 9, log b base n to the power minus m equals minus m times log b base n. So the power minus m comes as the coefficient of the log. Formula number 10, log b base 1 by n equals minus log b base n. Next, formula number 11, log b base square root of n equals half log b base n. So because of this square root, half comes as the coefficient of log. Formula 12, log b base n equals log a base n times log b base n. So a log can be expressed in terms of two logarithms with a multiplication sign. In this case, the base of the first log is the number for the next log, and this n comes from the left side, and the next log has same base as the left side. This is how we can express one log in terms of the multiplication of two logarithms. This is formula number 12. Formula number 13, log b base n equals log a base n divide log a base b. So a log can be expressed in terms of the division of two logarithms. In this case, the base goes in the second log as the number, and both log has same basis a, and the number of the left side log comes in the number of the first log in the right side. So this is how a logarithm can be expressed using the division of two logarithms. This is formula number 13. Formula number 14, b to the power log b base n equals n. In this case, this b and the base of the b are cancelled with the log, and only the number remains on the right side. This is how formula 14 works. Next, formula number 15, e to the power log e base n equals e to the power ln n equals n. Log en is called natural log, or it is called as ln n. So this is how formula 15 works. Formula number 16, m to the power log b base n equals n to the power log b base m. In this case, m goes to the number of the second log, and this number of the first log goes as n in the right side. So opposite numbers are assigned with log. Since here m is the base of the log power, so m goes as the number of the log in the right side, and n is the number in the first log, goes as the base of the power in the right side. This is how formula 16 works. Next, formula 17, if log b base m equals log b base n, then we have m equals n. In this case, both has log base b, but m and n are different, so they can be equal. Formula number 18, if m to the power log base p equals m to the power log base r, then we can write p equals r. In this case, this m and m is equal. Also, the base b are equal, so we can write p equals r. Formula 19, if m to the power log base b p equals n to the power log base b p, then we can write m equal n. In this case, base b and the number p both are equal, so we can write m equals n. Formula 20, this is the last formula. If m to the power log a base p equals m to the power log b base p, then we can write the bases are equal. In this case, m and m is equal, and also the number of the log p and p is equal. So the bases a and b are equal. So this is formula number 20. So these are the important rules and formulas for exponential terms and logarithm terms. This is the end of the video. Thanks for watching the video.